with the next chapter, the types of single-phase transformers. The various types based on the construction of single-phase transformer are core type, shell type. Coming to the first one, core type transformer. It has a single magnetic circuit. The core is rectangular having two limbs. The winding encircles the core. The figure, you can see the schematic representation of the core type transformer. Figure B shows the one shell type. The coils used here, cylindrical type, wound on helical layers with different layers insulated from each other by paper or mica. Both the coils are placed on both the limbs. The low voltage coil is placed inside near the core while high voltage coil surrounds the low voltage coil. Core is made up of large number of thin laminations. As the windings are uniformly distributed over the two limbs, the natural cooling is more effective. The coils can be easily removed by removing the laminations of the top yoke for maintenance. You see here's the second one. The second picture is shell type. It has a double magnetic circuit. The core has three limbs. Both the windings are placed on the central limb. The core encircles most part of the windings. The coils are used generally multi-layer disc type or sandwich coils. The core is laminated. While arranging the laminations of the core, the care is taken that all the joints at alternate layers are staggered. This is done to avoid narrow air gap at the joint right through the cross section of the core. Generally, for very high voltage transformers, the shell type construction is preferred. As the windings are surrounded by the core, the natural cooling does not exist. You can see here the schematic representation of core type transformer as well as shell type transformer. Here you can see the windings are surrounded by the core. The natural cooling do not exist. For removing any winding, what happens for maintenance? Large number of laminations are required to be removed. This is one you can keep in your mind. This figure shows the schematic representation or outway view of the construction of the shell type transformer. How do you compare core type with the shell type? Core is the winding encircles the core, whereas shell type, the core encircles most part of the windings. The second point is the cylindrical type of coils are used, where in core type. In shell type, generally multi-layer disc type or sandwich coils are used. In core type, windings are distributed, but here the windings are surrounded by the core. Here in the core type, the coils can be easily removed from maintenance point of view. But in shell type, the removing any winding for the maintenance, large number of laminations are required to be removed. This is very, very difficult. Coming to core type, the construction is preferred for low voltage transformers, whereas shell type, the construction is used for very high voltage transformers. Core type, it has a single magnetic circuit, whereas shell type has double magnetic circuit. Like this, you have many advanced comparisons between core and shell type. Next, we will go to the EMF equation of a transformer. You can see, so there are so many number of turns. When the primary winding is excited by an alternating voltage V1, it circulates alternating current, producing alternating flux that everybody knows. Okay, what happens here is the primary winding has N1 number of turns. The alternating flux phi linking with the primary winding itself induces an EMF in it that will be called as E1, capital E1. The flux links with the secondary winding through the common magnetic core. It produces induced EMF E2 in the secondary winding. This is called as mutually induced EMF. Even transformer works on the principle called mutually induced EMF. The primary winding is excited by purely sinusoidal alternating voltage. Hence, the flux produced is also sinusoidal in nature, having maximum value of phi m. You can see that in the diagram waveform. Phi m is the maximum flux it's producing. The various quantities which affect the magnitude of the induced EMF are phi and phi m. You know N1 that have written N1, N2, where phi is the flux, N1 is the number of primary turns, while the primary turns, number of secondary turns are N2, and E1 is RMS value of primary induced EMF, E2 is RMS value of the secondary induced EMF. Now, from Faraday's laws of electromagnetic induction, the average EMF induced in each turn is proportional to the average rate of change of flux. Average EMF per turn is nothing but d phi by dt. So using that, we have got, if you derive, you will land up with the relation E1 is equal to 4.44 F phi m N1 and E2 is equal to 4.44 F phi m N2 if you express in terms of phi m. As phi is sinusoidal, the induced EMF in each term, you can see that this is for sinusoidal quantity, what is form factor is given by. Form factor is using that form factor RMS value by average value. It will be continued, the derivation will be continued further and you will land up with the final relation of E1 and E2 that I have discussed here, that I have shown here. So today we are completing the EMF equation of a transformer and we discussed the types of transformers.